Okay, Algebra 2 friends, today we're going to continue with simplifying square roots. We did a little bit yesterday, we're going to take them a little bit further today. So yesterday we looked at simplifying square root 32, but we didn't have this 5 out front. So let's see how that 5 affects our answer. So we know that the square root of 32 can be broken into a perfect square, and the biggest perfect square that goes into 32 is 16. So this is 16 times 2. So we're going to split this up into square root of 16, square root 2, and this little 5's just staying out front. And then hopefully we all recognize very quickly why we did that, because the square root of 16 is 4. And so now we have 5 times 4 times the square root of 2. 5 times 4 is 20, so we have 20 root 2. Done. Number 2. Number 2 is not simplified because there's a radical on the bottom. There's a square root on the bottom, and you just can't have that. That's just not simplified. So we're going to get rid of this radical on the bottom. This irrational number here, we're going to get rid of that by rationalizing the denominator. Okay, so you can see both on number 2 and number 3, there's a square root on the bottom, and our goal is to get rid of it. Get it off the bottom. It's okay if it's on top, not okay on the bottom. So what we're going to do is multiply by the square root of 3. Well, we can't just stick something in there. We can't just multiply by 3. That'll change the whole value of this. But what can we always multiply is the number 1. Root 3 over root 3 is the number 1. It simplifies to be 1. Anything times 1 is going to be itself. So no problem, we can multiply by 1. We will change the look of our expression. We will not change the value of the expression. So now we have fraction times fraction. We multiply across the top and across the bottom. So on the top, we just have 6 root 3. We can't combine those at all. We just write 6 root 3. On the bottom, we have square root of 3 times square root of 3, which is square root of 9. Now our whole purpose here is to get rid of this square root, and how did we do that? Well, what we ended up with down here was a perfect square. And what is the square root of 9? It is 3. So now what we have is 6 square root 3 over 3. Now hopefully you're looking at that and thinking that, oh man, that fraction can probably be simplified. Yes, it can. Not the 3 over 3, because on top that's not a 3. That's a square root of 3. What can be simplified is the 6 over 3, which will reduce to 2 over 1. So 2 root 3 over 1, or just 2 root 3. Done. Number 3, same concept, but the algebra is going to be a little bit different, so I'm going to go ahead and do that one also. Get rid of the square root 5. We're going to do the exact same thing we did on number 2, and we're going to multiply by root 5 over root 5. Okay, that's going to be that same process anytime there's a single square root on the bottom. Multiply across the top, we get square root 30 over 2. Root 5 times root 5 is root 25. The whole purpose of doing that was to get a perfect square inside the radical, because the square root of 25 is 5. And so now we have square root 30. Oops. We have square root 30 over 2 times 5, which is 10. The root 30 and the 10, the 30 and the 10 cannot be simplified. You can only simplify square roots with square roots and numbers with numbers. Moving on to number 4. Notice these also have square roots on the bottoms. However, they have this plus and minus signs along with them. So these are a little bit of a different process to get rid of the square root. Again, you can't have a square root on the bottom. So what we're going to do is multiply by the conjugate. Okay, and all that means is we take what's on the bottom here and we change this sign. This is 1 plus root 5. I'm going to multiply it by 1 minus root 5. Over here, this is 2 minus root 3, and so we're going to multiply by 2 plus root 3, but we'll come back to that when it's time. Again, we want to multiply by 1 so that we're changing the look of our equation or our expression and not the value. So this is 1, so this is okay. So now on the top, we're going to have 3 times times 1 minus root 5. So we can actually put in some parentheses here if that makes you feel better. And so we're going to distribute this 3. We're going to distribute the 3 to the 1 minus root 5. So 3 times 1 is 3 minus 3 root 5. And then on the bottom, we've got a binomial times a binomial. We've got 2 terms times 2 terms. And there's the bell, but you can't be done yet. Anyway, we're going to FOIL. So we're going to FOIL. I'm going to write it all out so you can see every step. We've got 1 times 1, which is 1. We've got 1 times minus root 5, which is minus root 5. We've got 1 times positive root 5, which is plus root 5. And then we have root 5 times root 5 with a negative here, so this will be minus root 25. Now it looks like a little bit of a mess, however, it's not, because it simplifies nice and pretty. The top stays the same. Can't do anything else with that. The bottom here, we've got negative root 5 plus root 5. Those cancel out. Notice this is like our perfect squares, okay? When we have x plus 3 times x minus 3. The only thing different is the sign. So these middle terms cancel out. And this is a pretty perfect square. So what we end up with here is 3 minus 3 root 5 over 1. Then these are canceled. Minus square root of 25 is 5. 1 minus 5 is negative 4. So we have 3 minus 3 root 5 over negative 4 and simplified. Okay, a lot of work, but you got to get that square root off the bottom. You can't have it down there, so just work slowly through these. All right, I'm going to do one more similar problem. They're just flip-flopped around just so you get used to seeing it a different way. So the first thing we're going to do is decide what the conjugate is, and that's the opposite. So I'm going to multiply by the conjugate here, which is going to be root 2 plus 3. Whatever we do on the bottom, we also must do on the top. So we can throw these all into parentheses. It helps with our distributing and our foiling process. And then we're going to distribute on the top. 2 root 2 plus 2 times 3, which is 6. And then on the bottom, if we FOIL all this out, we're going to have square root 2 times square root 2, which is square root 4. Our outer term is 3 root 2, so plus 3 root 2. Our inner term is minus root 3, or minus 3 root 2, so minus 3 root 2. And then our last term is 3 times 3. It's a negative, so negative 9. Again, we're going to simplify. Those middle terms cancel out. They always should if you're multiplying by the conjugate correctly. And square root of 4 is 2. So that simplifies to 2 root 2 plus 6 over 2. This goes away, minus 9. So that becomes negative 7 on the bottom. So 2 root 2 plus 6 over negative 7. The end of notes. Now you have examples. So work through these 4 examples and we will go over them together and put the answers up in class tomorrow. Good luck and enjoy.